In this section, we'll explore the object-oriented features of Python. But before that, I want to give you a general idea about programming paradigms and object-oriented programming. Programming paradigm is an approach to organize and structure your code. It is actually a style of programming. The two common programming paradigms are procedural programming paradigm and object-oriented programming paradigm, also known as OOP in short. In the procedural paradigm, there is a step-by-step procedure that is followed sequentially for solving a specific problem. It is implemented through code blocks called functions. The program is organized in a way such that the functions process the data of the program. In object-oriented programming, real-world entities or concepts are modeled using objects. An object has both state and behavior, means it contains both data and code to manipulate that data. So in procedural programming, you model your program in terms of functions, and in object-oriented programming, you model your program in terms of objects. Programming languages are designed such that they provide features to support one or more programming paradigms. For example, C is a procedural programming language as it has functions, but it has no features for object-oriented programming. Java and C# are examples of object-oriented languages. Python is flexible as it supports both these programming paradigms, and it is up to the programmers to choose the suitable one according to their problem. You can even mix both the approaches to accomplish your specific task. So far, we have been using procedural approach. We have learned everything about functions. Now we'll see the object-oriented approach. So in this lecture, we'll see what object-oriented programming is, and then in the rest of the section, we'll see how to implement object-oriented programming in Python. First, let us see the common terms used in object-oriented programming. Classes and objects are the two main components of object-oriented programming. Suppose you are making a library management system. You might want to model different users as objects. Each user will have a name and an ID, and each user can borrow a book or return a book. You will also need to represent different books as objects. So suppose each book object contains title of the book, ISBN number, author name, and a book can be issued or deposited. So we can see we generally need to model real-world things that have similar behavior but differ in their internal state, which means that their data is different. For example, here all the user objects can borrow a book or return a book, but all have their own data. Similarly, all these book objects have similar behavior but different data. When we need to create an object of integer or string type, we can use built-in types. But when we have to create different type of objects that our program requires, we have to define our own type. These new types are called user-defined types and are created using classes. To create these objects, we can define a class called user, and to create these objects, we can define a class called book. A class is a blueprint for creating the objects. A class actually specifies what data its objects will have and what behavior will they exhibit. When we define a class, we create a new type. The values of this new type are called instances or objects of that type. Each object that is created from this class will have this data and this behavior. Creating a new instance of the class is called instantiation. Classes encapsulate state and behavior together. This is called encapsulation. State is maintained through variables, which are also called data members, and behavior is implemented through methods. Methods are like functions, but they are defined within a class. So a class defines what data and methods should the object have, and the objects contain the actual data. And instantiation means creating an object using a class as the blueprint. Now the behavior defined inside the class is shared by all the objects, but data is not. Each object behaves in the same way but has its own data. This means that the methods defined in the class are shared by all the objects, There is only one copy of each method which is used by all the objects, while each object maintains its own copy of variables. So you can think of class as a template that is used to create objects that behave in the same way and have their own data. One of the advantages of object-oriented programming is code reusability. Classes that you define can be used by different applications. Then you can inherit from these classes to make new classes. This reduces development time and effort. Then there is a sort of data security as the data is encapsulated inside the object, and hence there are less chances of it being misused by other parts of the program. You can hide all the inner workings of the class from the user of the class. This hiding of the internal working of a complicated system from its user is called abstraction. Polymorphism, which means one thing many forms, can also be implemented in object-oriented programming. Now in the next lecture, we'll see how to create classes and objects in Python. But before going to the next lecture, I want to clarify the terminology used in Python so that you don't get confused between the terms objects and classes. We know that everything in Python is an object. Integers, strings, functions, modules, all these are objects in Python. When you define a function object is created. Similarly, when you define a class object is created. And these objects that are created from the class are called instance objects or just instances. So Python supports the concept of classes and objects through class objects and instance objects.